My name is Katie Denise. My pronouns are she, her, and I'm a second year agriculture business student minoring in data science. I'm a BEACoN mentee working with my mentor, Dr. Ahmed Deef, on a project to understand the impact of digital twins on agriculture supply chain performance. Before I dive into the research itself, I want to touch on the mentorship I have been afforded in the BEACoN program. Dr. Deef has empowered me as a student to learn more and be a better researcher. I am extremely lucky to have this opportunity as I was given the opportunity to join the second quarter of the BEACoN program. Dr. Deef, thank you so much for the time and guidance you have given to me this last quarter. Now to dive into the research. Firstly, it is important to have some background on digital twins and the agriculture supply chain. The agriculture supply chain itself is extremely complex, and the reason for that is because there's uncontrollable variables involved, such as environmental factors and a limited shelf life of products. But what is a digital twin? A digital twin is an evolving digital equivalent of a real life process that uses historical and current behaviors to optimize business performance. So, to couple a digital twin with agriculture, it would allow farmers to reshift their focus and focus more on consumer demand and less on trying to figure out the weather. So, in addition to shifting farmer focus away from uncontrollable variables, there are other benefits to digital twins. Digital twins would increase operational effectiveness on the farm, reduce operating costs, and allow the farmer to make better business decisions. Farmers' observations in the past have been measured to be generally wrong, whereas many of the machine learning models that can be integrated in digital twins have between 80 and 90% accuracies. Here is a visualization of a digital twin. Circled in red is the primary focus of this project, and these arrows point to the model-based transformations of information, where we're looking for models to transform the historical and current behavioral data to mimic the behaviors in agriculture. The objectives for my role in this much larger project were to identify 20 references with existing machine learning models, either prescriptive or predictive, for growing processes of various crops, specifically looking for crops grown in California, as well as to conduct a comparative analysis to compare and contrast different models in the agricultural supply chain to develop a comprehensive literature review that provides understanding for future research of applying digital twins to the ag supply chain. So the way that this research was approached was in three different parts. First, a general literature review was conducted. Then from there, we developed selection criteria to narrow it down. And then after that, we critiqued and did a comparative analysis of the papers. So first, in our general literature review, we developed a list of search terms to be searched on the internet to yield the results that we were looking for. Here's a list of some of the terms that were used in those searches. Specifically looking at strawberry predictors, strawberry wasn't always the crop that was used in that search. Other top California crops were used instead of strawberries, as well as crops that popped up frequently in the searches. And then from those search terms, we found over 2,000 papers, and the two main databases that all the papers were found in were Science Direct and Google Scholar. After the general literature review, the 2,000 papers needed to be narrowed down to a much smaller number. So the selection criteria that was developed is listed here. First, the reference must include the mathematical equation that was used to create the model. The model must be upstream in the ag supply chain. The model must have clear variables involved, and the model must be about a food crop, so no animal agriculture or crops such as cotton. And from the selection criteria, it was narrowed down to 20 references that could then be critiqued. After the 20 references were selected, the papers need to be better visualized so that we can analyze from multiple perspectives. So here's a sample of the table that was created with those 20 papers. You can see that we looked at them at title, features, crop, model, or algorithm, their functionality, so what was the goal of the reference, as well as how accurate the model was inside the reference. And ultimately, this just allowed us to conduct the comparative analysis better so that we could really understand the landscape of digital twins and its application in AI, where there's missing gaps, as well as to capture the high application areas currently in the field. Here's an example of one of the comparative analysis matrices that were created. Here we're looking at type of crop versus the focus, and you can see that there's only 4 focuses found across all papers. This is an example of another matrix that was created, and here we are comparing complexity versus accuracy, and we can see that most models are at least 70% accurate. So here are our primary findings. They all point to gaps in the research and point to valuable points that we found. So overall, we found that there's a lack of machine learning models implemented in digital twins. There's a heavy focus on yield predictions and a lack of focus on vegetation health and harvesting. And most models don't use prescriptive modeling, and most models are at least 70% accurate. So what's next? First is to identify an existing machine learning model that can be best implemented into a digital twin. Then to aggregate the information learned from this literature review with the work of the other students on the project. And lastly, it's to identify and model a California crop that can be incorporated into a digital twin itself.